And welcome again. Now I would like to move towards problems related to the force of surface tension. And this is a starter, and you can read the statement of the problem that says a homogeneous this rod of mass m and length 2a shown in the figure can rotate without friction about a horizontal axis passing through point O. Yeah, and a square frame with side length A is fixed in a vertical plane, right? And the rod stretches a soap film of surface tension sigma. Rod is rotating like this because it's a stretching the soap film, and the film is this. Set up the equation for equilibrium of the rod. Well, its rotation about fixed axis. So if I can think of the equilibrium of the rod, I should be thinking about the torque of gravitational force acting on the rod about point O, and this must be equal to the torque of force due to surface tension. So I guess surface tension forces will be acting on the rod like this. Yeah, this is the distributed surface tension force, and I don't know where exactly the half of the rod is, but if I can guess it is here, then I can see the force of gravity acting on it. And so the torques, I will be needing the length, this length of the rod as well. And mg is all there, and for the moment term I will be needing this length, that means this length as well, and I don't know how to find it. Yes, but I can do it, since this length I guessed is simply a, and this is angle alpha, so this length will be simply a sine alpha. And what is the total length, like this length of the rod in contact with the soap? It was soap solution or simply liquid soap film? Okay, and what was the length? I know I can see a right angle triangle here, so this right angle triangle I need to consider, and this length is A, and this length, suppose this length is L, so it's a geometrical work only. That means L cos alpha is going to be equal to A, and that means L is A upon cos alpha. So to find the torque of the force of surface tension, I simply needed the half length of L. The whole force can be assumed to constant. The whole force due to surface tension can be assumed to concentrate here, and well, this is easy to write because the torque of gravity about point 2 is clockwise, and torque produced by the force of surface tension about point O is in anti-clockwise direction. That means the torque of force of gravity can be simply written as mg multiplied by its moment term, that is a sine alpha, and the torque of the force of surface tension is the force is simply sigma L, because its length is L. So the force of surface tension can be simply written as sigma L, and its moment arm is L by 2. So moment of the torque moment of the force of surface tension can be written as sigma L square by 2, and that is something sigma by 2. L square is A square by cos square alpha. Yeah, and I have set up the equation perhaps, and this will be simply mg a. M is the mass of the rod. mga sine alpha, that must be equal to sigma by 2 A square by cos square alpha. And after calculating few things, manipulating few things, this is the equation, I think, for the equilibrium of the rod at the moment, as per this picture is concerned. So I think I have set up an equation, and nothing else has been said about a stable equilibrium or something else. So it's all right to end the problem at this stage, and thank you for watching.